All right, let's go over muscle endurance real quick. So we're talking about sustained muscle contractions. So sustained, repeated muscle contractions over a longer period of time. The past chapter we talked about muscle strength, and that's all-out effort. So it normally only lasts like 10 to 12 seconds. Here we're talking about events that are sustained, that we generate ATP to last around 2 or 3 minutes. So some common activities that would test muscle endurance would be push-ups for the upper body. So push-ups until they fatigued. Sometimes you do them timed. Time sit-ups, time lunges for the lower body. Sit-ups are for the core. Even for the core, you might do something isometric where you hold a plank position. And really what we're concerned about here is chemical energy, adenosine triphosphate. So we break off one of the phosphates, and that high energy covalent bond, when it's broken, releases energy. So anytime you go from a high energy state to a low energy state, there's an energy release somewhere. And that's how creatine phosphate supplementation works, is adenosine triphosphate gets knocked down to adenosine diphosphate when we break that high energy covalent bond. And to get us back to ATP, adenosine triphosphate, we break that phosphate off creatine, pop it back on here, and we get back to 3 phosphates. So where is all this happening within the body? So you have anaerobic glycolysis and you have aerobic glycolysis. So anaerobic glycolysis would happen like if you did push-ups to fatigue. That's happening within the cytosol of the cell. So you have glucose within that cytosol. It's broken down, and we net about 2 ATP. Whereas aerobic glycolysis, this is where we might go out for a long distance run. We take that ATP that was used in anaerobic glycolysis and we use it inside the mitochondria of the cell. Those are the powerhouse of the cell, and that nets us about 34 ATP. Most literature says anywhere from 36 to 38 ATP is generated aerobically. So you notice we netted 2 here and we got 34 here. We add those together. That's where they're getting the numbers from. That's a real basic explanation. So what I was getting at is these two systems are not independent. They happen together. But really our 3 main energy systems all work together. So this blue line represents the ATP-CP system. The red line represents glycolysis. And then the green line is the aerobic oxidative energy system. So you know in these first few seconds, we have to use the stored ATP within the muscle. But eventually, it's going to fade out. We're going to use it all up. But as we do that, glycolysis kicks in, and it supplies enough energy needs. So if we're still going and the intensity is not too high, the aerobic oxidative energy system can kick in and supply the rest of our energy needs. This is all based on intensity. How hard are we working? So you'll hear things talked about in exercise physiology like aerobic threshold and anaerobic threshold. Really more anaerobic threshold and lactate threshold. So lactate threshold would be that point at which lactic acid starts to build up in the body because we're not running off the aerobic oxidative energy system. The anaerobic system's having to kick in. And that's that anaerobic threshold is that point at which the aerobic system cannot keep up with the demands because the intensity is too high, and the anaerobic system has to kick in to help out. Now that can only be sustained for a short period of time, but I just want you to understand that these energy systems work together. They're not independent. Now I have a chart that kind of talks about the different muscle fiber types. Now here's something we haven't talked about before. You have slow twitch, you have type 2A, which is fast twitch oxidative glycolytic, but then you have an intermediate between fast twitch oxidative glycolytic, which is this one, and fast twitch glycolytic, which would be more strength training. And you notice we have this intermediate fiber. You don't hear this discussed about in literature too much, but there's a hybrid between these two. So it just depends on how you train. you can have a higher percentage. But most of the time you just hear it referred to as slow twitch or fast twitch, or the fast twitch being either type 2A or type 2B. You don't hear about type 2X too much. So percentage, muscle fiber percentage by athlete, if you were untrained, the average person is 50-50. Now this can vary somewhat through genetics, but on average 50-50. But through training, so if I was a middle distance runner, then 70% would be slow twitch and 30% would be fast twitch. If I was an elite sprinter, so this is almost all out effort, 80% would be fast twitch, 20% would be slow twitch, and this is just a rough estimate. So power lifters and people that lift weights tend to be 60% fast twitch and 40% slow twitch. And this is going to vary based on the muscle. So the deltoid, gastrocnemius, rectus abdominis all have a higher percentage of slow twitch because we use them throughout the day, whereas the quadricep, hamstrings, gastrocnemius, pectoralis major, triceps to a certain extent all have a higher percentage of fast twitch. So they're larger muscle groups. But those can all be changed through training somewhat. So blood pH and lactic acid. This is an important concept when it comes to muscle endurance training, because if blood pH drops much below 7.2 or 7.3, then your body can't buffer that acid. You may not have enough stored. So this is what happened. If you've ever done a lot of repetitions before and you've gotten nauseous from it, this is what's happening in your body. You don't have enough stored buffer, sodium bicarbonate, to buffer this lactic acid, and you can't get rid of it fast enough through breathing. So CO2 helps get rid of acid as well. So your body wants to get back to homeostasis, and so the fastest way for it to get rid of a lot of acid is for you to get sick and vomit, because there's a lot of acid in your stomach. So that's the reason some people get nauseous when they do a lot of repetitions, especially with large muscle groups, produce a lot of lactic acid. So pH and enzymes. So if your pH drops below a 7.2 or 7.3, then what can happen is it can mess up the enzyme function. And so proteins denature. So if you've ever, temperature can do this too. So if you get too hot, that can also mess up enzyme function. So pH and temperature are the two main ways where we will mess up those enzymes and they won't function, and then we'll have to slow down and let our body recover. So if you've ever cooked an egg and you saw the egg white go from clear to white, what was happening was the temperature caused that protein to denature. That's the easiest way for me to visualize it. And proteins can denature in your body, which enzymes are a collection of proteins. That's what we're talking about. So beta-alanine, this is an amino acid that can be converted to carnosine in the body, and the carnosine is a buffer. It helps you buffer lactic acid. This is one of the few ways that you can supplement to help buffer lactic acid. In the old days, they used to try to take large doses of sodium bicarbonate because we found that it was stored in the muscle. But unfortunately, it's not converted that way. It was just making people sick because they were becoming too alkaline. So proteins for muscle endurance, I hope you remember the recommendation of 1.8 grams per kilogram of body weight. That's just a rough estimate. So if you had no idea and you were going to do a lot of endurance training, that's what most literature will recommend. But the Academy of Nutrition and Dietetics and Dietitians of Canada and the American College of Sports Medicine gives you a greater range. So it really depends on the activity that you're doing. So they have a range of 1.2 to 2 grams of protein per kilogram of body weight, and it just depends on training. So you need to make sure that that's spread out, not taken in one lump sum, because your body won't be able to use more than 30 or 40 grams, depending on the person, at a time. And so you'll just end up filtering that out and peeing away the protein. And it's hard on your kidneys. So muscle endurance testing can be either isotonic, like you see with push-ups, or isometric, where it's more just holding a static position. So I'm trying to keep these videos short. I hope that helps explain muscle endurance. I will see you in the next chapter, which will be about cardiorespiratory endurance.